Greetings from the mountain path, the world of finance. So today we'll discuss retirement planning. So how to save a retirement corpus, how to calculate a retirement corpus, and how to calculate the monthly savings that is required to arrive at the retirement corpus with a few inputs in the model. We start with the assuming the current monthly expenditure as 35,000. The current age is 35 years. The retirement age is 60. And years to retirement is 25 years, that is calculated 60 minus and 35. Let's assume post retirement the number of years life expectancy is 25. The rate of return is 8%. The expected inflation is 6%. Now, these are all the inputs. Now first calculate what should be the future monthly expenditure at the time of retirement, which is simply the current monthly expenditure into 1 plus the inflation 6% to the power of the years to retirement, that is 25. Now multiply that into 12, so it will give you an annual expenditure at the time of retirement. Let's do some lifestyle modification input. So it's going to have, is requiring 80% of the requirement. So from 18 lakhs 2000, so I'm going to reduce the 20%. That means 80% of the annual and requirement is going to be the annual expenditure. This is the amount that is required for the next 25 years post retirement. So every year he requires 14 lakh 42,000 and as an annual expenditure. So we can, so that means to arrive at every year it's a kind of an annuity payment. That means he require, and we can put it as an annuity due. Now then we need to calculate the adjusted rate, which is nothing but the inflation adjusted annual rate, and to calculate the retirement corpus. So how do you calculate the retirement corpus using, and so we can simply use the present value function. We can use simply the P present value. The first thing is the inflation adjusted rate. The second is the number of years post retirement, that is 25. The third income is a payment. The payment is this is the amount. So every year required is annuity. And the next is the future value, we can give it as a blank. Then comma 1 for the beginning period. So we will get and 2 crore 90 lakhs and 70,000 as the retirement corpus that is required to get an every year annuity payment at the beginning of 14 lakh 42 for the next 25 years. Now this is nothing but the future value, because when you want to calculate the monthly savings required, we simply are going to use a PMT function. And since there is a monthly savings required, so that means we can say that PMT open bracket, then the rate is nothing but the rate of return and divided by 12 for the monthly and calculations. Then the number of periods post retirement is that is number of periods years to retirement is 25. 25 multiplied by 12 again for the monthly. The next is we require the present value is not required, so we can put a blank. Then we require a future value. Future value is nothing but and this one 2 crore 90, then comma 1 close the bracket. So we'll arrive at and 30,000 and 364.84 as the monthly requirement, actually. So this is how the retirement planning is done actually. So to arrive at a corpus of 2 crore 90 lakhs, so we're able to use PMT function, and so simply we can calculate. Only thing you need to put a minus for the future value inside the function, and we have to leave the present value blank. We are adding 1 and to calculate what is every month at the beginning, what is the amount that is required. So this is, let's do a simple data analysis using what you have done. For the same thing that you have done, how you can do a data analysis. So we'll get the monthly savings here. Then on the row side, we will put different inflation data, and on the column side, we will put different interest rate data. Now, if you use a data table, if you highlight the entire table, then we want to do for different inflation for different interest rate. So how we can calculate the monthly? So we can use a what if analysis in a data table. For the row input, it asks for the inflation. So the inflation is just take the inflation here as 6%. Then on the column input, and it asks for the interest rate. So you will take the interest rate here. You click OK. So we are able to get for various inflation as well as interest rate. So we can, whichever data you want, whatever inflation, whatever interest rate. So we can calculate our monthly savings required for the corpus. We can also do one data table analysis. So what is the monthly expenditure and for different retirement age? So we can highlight the table. So in the row side data is monthly expenditure and the retirement age a different age. So let's go into the again that what if analysis here and take the data table. So we can input the monthly expenditure is the data, and so the monthly expenditure is the input here, and then the column input we are losing retirement age. So the retirement age is actually 60. There is an input. If we click OK, so we are able to arrive at so the various and monthly expenditure required under a different retirement age, and so we can target many things. Then the final step, we can use what is called and our Python code and to run this retirement tool effectively. So you have to install import NumPy Financial as a NPF as a library. So you have to run the first pip install the NumPy Financial library. Then once it is installed, then the first is to define the various the function that we get the inputs the Excel, nothing but the current age, years to retirement, future monthly expenditure, annual expenditure, adjusted discount rate, retirement corpus, then the monthly savings required. So once you define the functions correctly, then we have to prompt the user for inputs, that what are all the inputs required, we can get the user to give the inputs. Then finally to calculate the monthly savings and display the monthly savings required. Let's run the Python code here. It asks for the current monthly expenditure. Let's say 35,000, what you have done in Excel, the same thing. Enter the current age, let's make it as 35. And enter your retirement age, let's say 60 years. Let's say the number of years and the expected life post retirement, let's make it as 25. Let's say post return and as a percentage post return, let's make it as 8%. You can incorporate 8%. Now the expected inflation, let's put it as 6% as per the Excel model. So you can simply say we get the monthly savings of and 37,956.05, which is nothing but the same input that we got in our Excel. So we can actually with the same unless we have the data. So we can simply get the data whatever we want, because we have done the modification, lifestyle modification here of 80%. If we put 100%, we'll get the same and results here. So Python code is very simple. Define the functions of getting the calculations and get the inputs from the user and display the output. So this is nothing but a simple retirement planning tool, and we can also use a data table to do analysis, and we can also use a Python code to quickly calculate and what is the corpus required, what is the monthly savings required. We can modify various input. Let's say that and the monthly expenditure is 40,000, and for the current age we can put it as 40 years. The retirement age you can put it as 50 years. Then the number of years post retirement you can make it as 20 here or even 15, and we can calculate the expected return as and 6%. Then we can put the inflation at 4%. So that means for various inputs we can get what is the corpus that is required and what is the monthly savings that is required. And we can also similarly, and in a Python model is very dynamic, we can put the inputs, we can get the monthly savings required to arrive at the corpus. Thank you very much for watching. We will see in the next session.